Hello, before I start Unit 2, I want you to do a fun activity. Use the letters in your name to make symbols for different elements. And as you do that, once you make all the names, then use the periodic table to find out what is the name of the element and its position on the periodic table. After that, we're going to start with the topic for today. This is Unit 2 for Basic Tools, Chapter 1. We're going to be studying elements, compounds, atoms, and molecules. And you identify them, and then we're going to study how we can distinguish their properties and what type of changes they undergo. Elements. There are 118 elements recorded on the periodic table. A few of them are shown over here. And a more detailed discussion will be done for this particular element and the periodic tables under Chapter 2. The elements are pure substances by themselves. They cannot be broken down further. Chemical compounds are composed of two or more atoms. For example, in this particular slide, we are sharing the reaction between sodium metal, a solid, and chlorine gas, which is a gas. When they combine together, they form a new substance, sodium chloride, which is basically your table salt. The chemical compounds, as they're made up of molecules or ions, a molecule is the smallest unit of a compound that retains all its chemical characteristics. The ionic compounds are described by formula unit because the ionic compounds are held together by electrostatic force, and therefore they are a repeat of this formula unit because they give a three-dimensional structure. Molecules are described by molecular formula. Both formula unit and molecular formula give you the types of elements as well as the number of atoms of each element. Another way of showing the different chemical compounds is, of course, by writing the formula, which we have just discussed. And then also we can do a model representation as shown in this particular table, where you have water as H2O, then carbon, a methane gas as CH4, shown in a model-filled description for that particular compound, ammonia, NH3, and carbon dioxide, CO2. The properties of matter can be observed without changing a substance into another substance. That means its composition remains same. Examples are boiling point, density, mass, volume. Chemical properties can only be observed when a substance is changed from one substance to another. Therefore, completely new substance is formed. The properties of the original substance is completely changed. Example, flammability, corrosiveness, reactivity with acid. Physical properties can be evaluated or described without changing the composition of the material. And the physical properties include color, odor, states of matter, density, boiling point, melting point, solubility, electric conductivity, volume, and hardness. Another schematic way of dividing the physical property is into two: qualitative, which consists of properties that do not require any numbers: color, odor, solubility, hardness, electrical conductivity. and quantitative property, which requires numbers and units to represent them as mass, temperature, melting point, and density. Chemical properties, on the other hand, we just try to answer the questions, whether it combines, whether it rusts, whether it goes combustion, whether does it tarnish, does it react, will it explode. When we get answers to these questions, then we can say that a chemical reaction has taken place. For example, iron rusts when combined with oxygen. Carbon, when burnt, produces carbon dioxide and water. No water. Carbon is just by itself, so carbon dioxide only. Silver tarnishes, turns black because of the sulfur in the atmosphere, and it gets converted to silver sulfide. Sodium reacts violently with water to form hydrogen gas and a solution of sodium hydroxide. Another way of defining the properties of matter is the use of intensive property, which is independent of the amount of substance that is present. And examples are density, boiling point, color. An extensive property that depends upon the amount of substance that is present, like mass, volume, energy. Extensive properties depend upon the amount. Again, another way of showing this. Then physical properties are always a function of intermolecular forces, that is, forces that hold the atoms together, and the type of forces that are available for molecules to hold the atoms together. And these bonds are studied in chapter 8 and chapter 11. Properties. Physical properties are affected by temperature due to molecular motion, for example, density. And density is one property that can be used to identify a substance and is defined as the ratio of the mass of an object to its volume. A chemical property always results in a chemical change as the composition of the material has changed. And it explains how one substance acts in the presence of another. For example, wood, when we combine it with oxygen and burn it, it provides water and carbon dioxide and heat. Combustion is generally a reaction in which heat and light is produced. The reactants and products are very different. Then chemical properties are really properties of elements and compounds are related to the periodic trends and molecular structure that is there, and basically define chemical changes. Physical changes in matter that do not change the composition of a substance. Chemical changes result in altered composition and a new molecular structure, resulting in new substances. Combustion, oxidation, decomposition. Examples, spoilage of foods. Properties. Physical properties are affected by temperature. And a physical change entitles no change in chemical composition. For example, solid iron melting in a blast furnace, ice cube melting from solid to liquid. Now, some examples and the techniques for identifying physical and chemical changes that are used in the laboratory are chromatography, separate components of mixtures which did not change the components itself. Electrolysis, chemical change, where water is broken down into hydrogen and oxygen. Now here we stated that physical property is temperature dependent, and this is the temperature dependence for density of water. You can see that at 0 degrees, the density of water is 0.917. At 0 degrees, the density of water is 0.99984. showing that the density of ice is less than the density of water, one of the few substances that are there, and therefore ice floats in water. At 4 degrees, it is seen that the density of water is the highest at 0.9997 grams per centimeter cube. And beyond that, at higher temperatures, the density seems to fall. Now, whenever a chemical reaction has to be observed or carried out, then we have a setup that is there. And in this case, it's shown how hydrogen and oxygen gas, when combined from different tanks, are combined and they burn. Then when they burn, you get water molecules formed. And this type of structure, if you see any oil or petroleum extraction center, you will see a flame burning, and there you can see that the methane gas that comes out is burned continuously in the into the atmosphere, producing water and carbon dioxide. Water and carbon dioxide are considered as environmentally heat-trapping materials that are there. And beyond this, you will find all kinds of self-study concept review. You have just go through this so that you know how to do it. And in this particular problem, that is where you are asked to find the density, I would suggest you use the hint, how much water was there at the beginning. And when you introduce the water, the substance into the water, see the water level, by how much it rose. The difference in the height of the water will give you the volume, and you have the mass. And so with that, density is being defined as mass over volume. You can use it to identify the substance. And this is another concept that is really very useful. Which gas would you use to fill balloons? You can see that the density differs for each type of inert gas that is there. And so you can answer the question. And once you finish that, then the last slide shows you a chemical reaction. And this, you can see that as the iodine solution is introduced into the container, a slow blue color develops. And with that, before I end this particular unit, we're going to lead to Unit 3, Energy Measurements and Units.